Hi Year 12. Here is the answers to exercise 8D exponential models sheet. So exponential relationships, hopefully you've read this from your textbook already, can be used to model practical situations. The few examples of exponential growth or decay from your textbook are population growth, compound interest, declining balance depreciation, and radioactive decay, and more recently, the spread of the coronavirus, unfortunately, around the world. As with quadratic models for practical situations, there may be restrictions on the values used for the two variables. For example, an exponential model involving time, t, we know that time should be greater than or equal to 0. Okay, so no negatives basically. So here's example number 1. I've done the answers for you. I'll just talk you through them. The question says, the population of an island can be modelled using the equation p equals 5,000, open brackets, 1.09, close brackets, to the power of t, where p is the population and t is the time in years. The graph of the equation is drawn on the right. So question A asks, which part of the exponential curve applies to the population model in this case? Well, we're referring to the positive section in this case, and I've circled it there in red. Okay, so there it is, nice and big there. Alright, so that's the only section we're actually going to need to use to answer our questions, because hopefully our population goes up and not down. So B then says, does the graph show exponential growth or decay? So hopefully you've read from your textbook. If it starts from the left and it goes in an upwards direction towards the right, that means it's a exponential growth. Question C says, what was the initial population of the island? Initial means starting, beginning. Okay, so that's always going to be found when we look on the x-axis where x equals 0. So on the axis where x equals 0, there's 0 there. We find that the line goes through the y-axis at 5,000. So that's our answer for C. The initial population of the island is 5,000. Question D says, use the graph to estimate the population after 12 years. So if I move over and make the graph a bit bigger, I find 12 in between 10 and 15, maybe a little bit closer to 10. Just do your best, depending on what you've got in a test. I'm able to make this bigger, so that just makes it a little bit easier for me. So you're going straight up until you hit the curve, and then you're going straight across to the left until you hit the y-axis. So I'm hitting it roughly there at about 14,000. So that's why my answer. Notice I've used approximately, because when we draw these things or we have a look at them, depending on how big the graph is, it's going to make it difficult for you to see. So always write an approximate answer. Question E says, how long did it take for the population to double? So we know that the population started where it cut the y-axis there at 5,000. So double 5,000 is 10,000. You'll notice the green line there. So I'm starting from 10,000 on the y-axis this time. I'm going straight across until I hit the curve, and then I'm going straight down. So if I have a look at this, it seems to be hitting somewhere between 5 and 10, maybe a little bit closer towards the 10 rather than the 5. So that means, green, follow the green line, it's approximately 8 years. Okay, so there's the first example. Now here's example number 2. Example number 2 says, the population of an island is modelled, so a similar thing, by the equation p equals 30,000, brackets, 1.02, close brackets, to the power of t, where p is the population, sorry about that, and t is the time in years. So we now have to complete the table. So if you're not very good at using the exponential key on your calculator, you're looking for one of these two keys. All right, sharp one is the top one. I'm pretty sure it's y to the power of x. X to the little power of a box is the one that you need on the Casio. Okay, so if you look at that top line there, I've got 30,000 times brackets 1.02 close brackets, press your exponential key, whatever it might be, to the power of 0. Okay, that's going to be the first one. Why do I do that? Because the first number in the top of my box is 0. So all you really need to be doing is just changing the number after you press your exponential. If you want on the Casio or on the Sharp, if you just backspace and just change that one number, that might save you a bit of time in the test. So have a go at that for me, please. Pause the video if you want. Check and see if you get the same answers as me, please. All right, make sure you always practice. Don't just go straight for my answers, because you've got to double check to make sure you know you're using your calculator properly. Pause now. and have a go at this table. All right, hopefully you're back now. So here we go. So now I have drawn that table on this graph down here. Now, the beauty of using an iPad is I can obviously make it bigger or smaller. So if this particular grid is too small for you, you might want to redraw it in your textbook, in your exercise book. I'll leave it up to you. So basically, along the bottom there, if you can see, I'll make it a bit bigger so you can see, I've made every 5 little boxes down the bottom. So every one little box along the horizontal actually represents 1 year. I was able to do that. And pretty much along my y-axis, I have made every little box going up roughly 2,000. So 5 boxes hits 10,000, 5 boxes 20, etc., etc. So I have taken my table from up here, there it is, and I've put all of those numbers into my graph. So I'd like you to stop and pause the video and try and do that yourself, because you have to be able to do this on your own. Once you're finished, you can restart again. Okay, hopefully, can you check yours? Did you get something like mine? Okay, notice it's only a gradual increase. That's fine. It's still a curve. It's not quite a straight line just yet, okay? All right, so now we have to answer some questions on our curve. Now, realize in a test, if you make a mistake in the curve, we will mark it according to whatever you have drawn. So don't panic too much about that, okay? Just make sure you always answer your questions according to what you have drawn. So question C first asks, what does the intercept of the curve with the vertical axis represent? So hopefully you need to realize where the curve starts at the y-axis. That means that's the starting population of the island, also known as the initial population. Second question, D says use the graph to estimate the population after 18 years. So you'll notice I found 18. Every little box represents a number. That made it easy. I've drawn a lovely green line going up. Hopefully that makes it easier till I hit the curve. And then I go straight across to the left until I hit the y-axis. If I make it bigger, you can see it's roughly, remember they're going up by 2,000s. So it's roughly about 44,000 according to my graph. Remember, it's according to your graph. So that's how I got 44,000. Estimate the time taken for the population to reach 39,000. Okay, so 39,000, sorry I didn't do that very well, is actually just half a box below 40,000. So the purple line going straight across represents 39,000, and then I go down. Again, remember this is always just an estimate. So I'm estimating it's roughly 13 years. I'm going off my drawn graph, so that's how I got 13 years. Remember, go off your graph. Question F says extrapolate, which means to extend, your graph to obtain an estimate of the time taken for the population to double. Remember, it started at 30,000, so to double, we double 30,000, we get 60,000. So you'll notice, that's why I've put up in black there, 60,000. I had to put in an extra 2 little strokes for 2 more boxes to get there. So if you go straight across and then straight down, I'm just outside by, I reckon, about a box outside my grid. So I've estimated it to be roughly 33 years. Again, go with what you've done on yours. Try and be as accurate as you can, however. So my answer for F was approximately 33 years. Now G is a bit tricky. G says, what is the percentage increase in population each year? Explain how you can work this out from looking at the equation. Alright, so if you remember the good old compound interest formula, then the part of the equation that gives you the percentage increase is the bit that's in the brackets. So if you remember in the compound interest formula, the brackets is 1 plus R. Remember that? Okay, so the percent, where R is the percentage, okay, so if inside our brackets it's 1.02, then that means that's the 1 plus R section. Okay, so what I have to do is I have to go 1.02 minus 1 to figure out what the percentage bit is. That's 0.02. That's my percentage in its decimal form. So then all I have to do is multiply it by 100, and that will give me my percentage answer of 2%. Okay, that should be an of. I'll fix that in a sec. Of 2%. Okay, so there's that one. So now we have example number 3. Michael purchased a car for $49,000. The car is depreciating, so that means it should be going down exponentially according to the formula V to the lowercase t equals A times B to the power of KT. Now this is basically just the depreciation formula, if you remember it, okay? So A is the original purchase price, okay? If you remember that from the depreciation formula. So Michael purchased it for $49,000, so that's our original purchase price. So what you have to do now is put all the information or the numbers they've given you in the question and put them in the formula. So down here you'll notice I've got B is 1.2 and I've got K is negative 0.75. So the first thing I'm going to do is I'm going to put these all into the formula to get a usable equation. This is very similar to what you're going to do in the exercise. So here's my formula. VT equals, so I've put the 49,000 in the front, times 1.2, and then I've put up to the, in the index position, I've put negative 0.75, that's a point, not a, and times T next to it. All right. So question A actually gives me another number. It says, what's the value of the car after 3 years? So I know that T is now 3. So in my formula, I am going to use everything that I just used, 49,000 times 1.2 to the power of negative 0.75 times 3. Now when you do this one on your calculator, if you're not getting the same answer as me, can you practice it please and see if you do? Then you might need to put what is up in the index in brackets. Okay? It works on the Casio, not sure on the Sharp, just double check for me. Okay, so you should end up with an answer of $32,511 and approximately 60 cents if you did the right working out. All right, question B says, Michael would like to sell his car at the end of the year that the value of the car first falls below $19,000. Determine when Michael should sell his car. So you'll notice I've got the formula there. I know that I want to know when it's going to first fall below 19,000. That's why that's in the answer position, if you wish, where the V to the lowercase t was. And I've got the same formula, just my t is not there. Okay, that's what I've actually got to find. So I wrote some notes here for you. Here they are. This is difficult to solve at this level. Okay, you might have done something different if you've done a different level, but this is the way we solve it at this level. I suggest you use trial and error. And what that means is you're going to substitute a year number in the place of the T up in the index position until your number answer, where the less than 19,000 is less than the $19,000 mark. All right, so here we go. So the red one is my first try. All right, so I'm going to do a couple of tries until I get the answer. So I tried 1 first of all. Let's try with 1. So 49,000 times 1.2 to the power of negative 0.75 times 1 gave me an answer of 42,738. I'm nowhere near 19,000, am I? So I'm going to try a number that's a bit higher, because otherwise I'm going to be here forever if I go 2, 3, 4, 5. All right, so here we go. So now I'm going to try 5. 49,000 in purple times 1.2 to the power of negative 0.75 times 5. This time I get 24,732. Getting a bit closer, so I might just go up by 2s now. So now I'm going to try 7. So this time I try to the power of negative 0.75 times 7. The value of the car this time now is 18,815. Yay! I'm below 19,000. So I'm just going to double check and see what happens to make sure that 6 isn't my correct answer. So when I put 6 up the top, I get 21,572. So 6 is definitely not my answer because that's too big. Now it's up to you. Some people like to be a little bit more pedantic. I tried a couple of different decimals now between 6 and 7. So I think I started with about 6.3 and then I went 6.4. And I actually found that when I put in negative 0.75 times 6.6, that was when the price first dipped below 19,000. All right, so if you want to be a little bit more pedantic, you could do that if you want. So that means that my answer is that as long as he sells the car after approximately 7 years, the price will be below 19,000. Thanks, Year 12.